Bueno, ¿cómo andan? ¿Cómo la están pasando en la BitConf este año? ¿Bien? Hagan algún gesto, hagan algo, después dicen... Sí. Ahí está, vamos, vamos. Bueno, muchas gracias por venir. Ahora vamos a pasar a un tema bastante técnico. Digamos, tenemos a una flamante core developer de Bitcoin que nos va a contar, digamos, cuáles son los próximos, las próximas mejoras, los próximos desarrollos que se vienen en el core de Bitcoin. Así que les pido un gran aplauso para Gloria Zhao. Gloria. The stage is yours.
Thank you. Hello, you can hear me? Hi. I'm Gloria. I work on Bitcoin Core, mostly in mempool and peer-to-peer. And I'm here to answer a question that I get asked a lot, which is, what are the next Bitcoin protocol improvements? And I've found that typically when people ask me this question, what they're really asking me is, what is the next soft fork, and when is it going to happen? So today we're going to go through all of the soft forks that are planned for activation in the next year, 2023. Thank you for coming to my talk. I'll see you guys next year. Okay. Just kidding. So there are no soft forks planned for activation in the next year, I'm sorry, but that does not necessarily mean that there are no protocol improvements happening, right? And that's one of the main points today. So let's talk about protocol improvements. First, let's talk about what is protocol. So what makes a Bitcoin node a Bitcoin node? How many of you think a Bitcoin node requires a wallet? With a show of hands. Okay, probably not. What about a mempool? No? What about a blockchain? Okay, well, I thought there might be a few hands, but yes, I agree. I don't think it needs any of those things to necessarily be a Bitcoin node. All it needs to do is be able to speak the peer-to-peer protocol, because as you know, you can join the network and not have anything in your blocks database and do IBD and then eventually sync to the most work chain, right? And so as some of you may have noticed meeting me this week, when two people don't speak the same language, some of us get a little confused. So computers are the same. We have to have a peer-to-peer protocol for two nodes to communicate. And that includes, in the beginning, a version handshake where you negotiate, hey, I use this protocol version, I understand these messages, I'm going to send adder version 2, and I would like to relay transactions with WTX IDs, for example. And then that negotiation then informs what kind of communication you're going to do for the duration of that peer-to-peer connection. And that, okay, so the peer-to-peer protocol includes, for example, how we serialize transactions, how many blocks, how we serialize blocks, how many transactions there are, the serialization format for each transaction, the witness data, and so on and so forth. And of course, this is necessary so that when two nodes send a block to each other, the other one actually knows how to deserialize and invalidate it. And so again, you can join the network with absolutely no idea of what the chain state is. You can download the blocks or you can just drop them on the floor. As long as you speak the peer-to-peer protocol, nobody's going to disconnect you and you can just hang out. But of course, to be useful to a person, you want to be able to download blocks, validate them, right? So when you deserialize this block, you want to know, okay, I want to look at these transactions. Are they valid transactions? And how much money does each person have at the end of this set of state transitions, right? So a fully validating Bitcoin node also understands consensus, right? They're able to apply the consensus rules and answer these questions. Conversely, one that does not know the consensus rules will not be able to answer this question of, are these transaction valid payments, and how much money does each person have at the end of this block? And that's very important. So a fork happens when different nodes on the network have a different way of answering these questions of, are these valid transactions? And of course, in that state, there are certain nodes on the network that are unable to answer the question of how much money does each person have. And so I want to stress how risky it is for forks to happen. But of course, we do this intentionally in a soft fork such as Segwit or Taproot. But my main point is soft forks are kind of overrated. They're very risky, and I think we should try to do them as infrequently as possible. But I think the hype for soft forks comes from the fact that it requires so much community participation and collaboration for it to happen. But again, just because there are no soft forks happening does not mean that there are no protocol improvements. So there's no forks today. Today I'm going to talk mostly about peer-to-peer protocol improvements. So let's start with something quite simple. This idea of privacy, right? So currently nodes on the network will communicate in plain text. It's unencrypted, so you can imagine an ISP that is monitoring the network for Bitcoin-related traffic. They're able to see that, this node has sent a transaction message to this other node. And this might not be super problematic on a small scale. However, if you imagine someone trying to monitor the entire network, and they're logging when they see transaction messages being sent, they'll be able to say, hey, this was the first node that announced this transaction. There's a pretty high likelihood that that was the originator of the transaction. The wallet is that node. And so at that point, it doesn't matter if you escape chain analysis, you have perfect coin selection, you're doing coin joins, submarine swaps. Even if you had zero knowledge proofs for everything and nothing was on chain, now we've linked an IP address with your address, and that's just terrible privacy, right? And so BIP 324, did it change? BIP 324 is a proposal to then encrypt all traffic between nodes, or opportunistically. It's not authenticated encryption because there's no concept of identity on the network, but nonetheless, you make passive eavesdropping much more expensive, because in order to understand what is being sent on a connection, you have to be participating in it, right? So there's one protocol improvement that will not affect any of your wallets or how you use Bitcoin to send and receive payments, but makes everything more private for everyone, right? So protocol improvements are great. All right, now let's go to a concept that is slightly more complicated. So imagine you are this node on this peer-to-peer network, you're the red node. One of your key goals is to always know what the most worked chain is, right? So that you can know how much money you have. And unless you're mining all the blocks, you require someone to send you the blocks when they come out, right? So let's imagine in this hypothetical scenario that the blue nodes are miners. And so each time they find a block, they're going to propagate it to their peers, and eventually, hopefully, you get it. But in this case, there's anywhere from 6 to 10 hops to get to you. And so it might take a while. And also it doesn't even include the fact that those two peers that you're connected to might be actively trying to prevent you from learning about the most worked chain. So they're trying to eclipse you, maybe to try to get you to believe that they've paid you when they haven't, for example. So we want to avoid eclipse attacks. And also from a network-wide perspective, this topology sucks. Because, for example, if you imagine these two nodes finding a block, each finding a different block, that is, within a few seconds of each other, it's going to be a race to propagate, and some half of the network is going to see one block as their new chain tip, and the other half of the network is going to see a different block as their chain tip. Of course, it's going to be resolved over time because you're going to build on the most worked chain, and then that eventually prevails, but this kind of inefficiency is something that we want to avoid, and especially when they have different transactions in those blocks, a double spend, for example. That can be quite dangerous. Okay, so we would prefer a network topology to look something like this. So for example, if every single node was connected to every single other node, then we wouldn't have the problem of essentially stale blocks, right? There wouldn't be any races because everyone would immediately know whenever a new block was found. However, from the perspective of working on Bitcoin Core, for example, and we want to increase the default number of outbound connections that nodes are going to make, we have to consider what the network bandwidth cost is, right? So we want anyone to be able to participate as a fully validating Bitcoin node with minimal requirements. So that includes the Raspberry Pi nodes, that includes ones with very, very low storage, and that includes those with low network bandwidth as well, or those that would need to pay a lot of money for their internet usage if there was a lot of activity on their Bitcoin node. And so we want to see where the pain points are if we are to scale up the number of outbound connections by default for each node on the network. Okay, so one of those pain points is announcements. So just to clarify, obviously when everyone is more connected, that doesn't mean there's more blocks that are being sent. It doesn't mean that you're going to download transactions over and over again, but we do announce everything that we get to all of our peers in an effort to make sure everyone hears about everything, right? So when you get a transaction, you're going to flood your peers, with the transaction hash that you've just received. So that's only 32 bytes, 36 plus the type, but it's low, but with very high volume, right? It's quite common to have hundreds of thousands of transactions on the network every day. At high volume, this really makes a difference. So here's how it works. The first node is going to forward it to all of its peers. They're going to forward it to all their peers, and so on and so forth. And this causes peer connectivity to scale poorly in terms of network bandwidth. Okay, so here's a graph from Gleb Nomenko's paper about Erlay, where they're showing, if you increase the number of outbound peers, this is what happens to your bandwidth usage for a transaction relay. So Erlay proposes, rather than flooding, a set reconciliation mechanism to announce transactions between peers. And so instead of, you send hashes of all the transactions you get to all your peers, periodically, you and your peer will create little sketches, and you'll exchange that. Well, one person will send it, and then the other person will combine it and send the diff over, and then you only announce the transactions that the other peer does not have. Right? And so in situations where two nodes have roughly the same transactions, which is very common, you won't have a situation where you're sending duplicitous redundant transaction announcements. And so obviously there's not zero overhead, but this means that instead of transaction announcements being per connection, it is per node, roughly. And if this is a bad illustration, just imagine that each node is connected to 50 other nodes, because we're changing the bandwidth usage from the number of connections to the number of nodes. So it scales better, and we can then introduce more outbound peers by default per node without blowing up the network bandwidth usage that makes it unacceptable or inaccessible for people to run Bitcoin nodes. So there's Erlay, and again, this does not affect how people use transactions in their wallet, and it's just, it's making transaction relay slightly more efficient, but it means that we can increase the connectivity on the network, which again is great for the topology, and makes each individual node more robust to eclipse attacks. So this maybe abstract concept of security is translated to this lovely library of math and interesting nerdy goodness. Great. Next one. And it wouldn't be a presentation by me if I didn't mention package relay. So how many of you are familiar with child pays for parent, CPFP, the fee billing mechanism? Awesome, great. So for those of you who are not familiar, the idea is you have an unconfirmed transaction. You put a fee rate on it, but now you want it to confirm a little bit faster. So what you do is you create a child transaction that spends the output from the original transaction, and you put a really high fee on the child. And that has a dependency relationship on the previous transaction, so child and parent. And miners will understand, like, hey, I get really high fees if I mine both of them. So you've effectively increased the priority of the first transaction. Great. The caveat is, of course, when there's very high network traffic of transactions and mempools are not infinite in space. Again, we want a Raspberry Pi to be able to run it. And so it'll start evicting the lower fee rate transactions, effectively raising the mempool minimum fee rate to get into the mempool for each individual node. There's no such thing as a mempool. And so this becomes a problem if your parent transaction is below the mempool minimum fee rate, because then you're out of luck. You're just going to have to wait for the mempool to clear, or you need to sign a new transaction, which is sometimes impossible if it was some kind of contracting protocol with an untrusted counterparty. Okay. Another problem is on the peer-to-peer network, there are no guarantees in which order you're going to receive these transactions. So you need the parent in order to validate the child, but there's no guarantee that you're going to have the parent when you receive the child. And so this is probably just a little bit too much of a sausage. I'm blowing up the implementation details and putting it on a screen in front of people that don't care. But when you receive an orphan transaction and you have not seen one of the inputs because it's still waiting to propagate to you, right now your only solution is to take that prev out and the TXID that it specifies and request the transaction by TXID. The problem is that TXIDs do not commit to the witness data, and so if someone else is announcing this transaction to you via WTXID, you wouldn't even know because you don't have the transaction yet. There's no way to deduplicate if the transaction ID and WTXID are different. So again, maybe too much of a sausage, but the idea for package relay is to, instead of looking at transactions individually, be able to validate and send them as a package. And this makes fee bumping more reliable for users. So there's actually a change in user experience here. And also makes transaction relay more robust in general. And for L2 protocols such as Lightning and commitment transactions, you can put 0 fees on your commitment transactions and only pay the amount necessary at broadcast. So hopefully in situations like unilateral channel closes where they just went offline, it's not a malicious situation, you don't need to overpay. You just pay exactly what you need. And maybe this will save people a bit more money. Okay, great. So hopefully I've convinced you that it's not just soft forks that make Bitcoin better for everyone. Peer-to-peer protocol improvements are great. They help nodes communicate more efficiently, more quickly, more securely, or about information that they couldn't before, such as the relationships between transactions. And even if they don't change the way that wallets behave or users interact with their payments, they make Bitcoin better for everyone in these kinds of abstract ways. So hopefully these abstract concepts of decentralization or privacy or security have now been translated into actual technical challenges and code for you to look at, and I hope that I've nerd sniped somebody, and so I wanted to add a couple slides about how you can participate in protocol development. I don't think there's any such thing as like, oh, I'm not technical enough or whatever, because I think most people have experienced, like, you know, I've accidentally learned how to code because I was really interested in how this thing worked. So for those of you that want some homework, I highly encourage you to subscribe to the OpTech newsletter. It is a weekly summary of all the interesting discussions and proposals and debates and and releases that have happened in the past week. And it's written by devs, it's reviewed by devs. It's not written by marketers, there's no bullshit, there's no ads. It's just pure information, and there's summaries about technical topics. It's translated in a few different languages. It's great. And the second piece of homework is attend a BitDevs in your city, or if there isn't one, please start one. I can highly recommend the New York BitDevs Socratic Seminar notes every week. Again, it's everything from like protocol level research to applications and improvements in Lightning UX, like everything you could possibly be interested in. You might meet some cool nerds there that you become friends with. So I highly recommend that. Thank you everyone for coming to my presentation. I appreciate you listening.